Hi and welcome to the third section, implementing update and delete through a RESTful API. In this section we will learn how to implement update and delete CRUD operations, what hypermedia means, and we will see how to implement pagination for our API. Now we move on to the first video of this section that deals with implementing the update CRUD operation. By the end of the video you will learn what HTTP verb should be used for update operation and what HTTP response codes should be sent once the update operation has been executed. In this video we are going to take a look at the characteristics of the update CRUD operation, and we are going to review the Flask code which implements the implementation of this operation. The update operation is mapped to the HTTP put verb. The update and the HTTP put methods are not safe operations. These are always changing data on the server side, and they can change the state of the application too. When implementing the update operation, the HTTP put request body normally contains the fields which we want to update in our entity. There are two approaches when implementing the update operation. The first approach is to save the data in the request body if that does not exist in the database. In the second case, the response should return an HTTP 201 error code and contain the access path for the newly created entity in the HTTP headers. The second approach is more restrictive. In case we send the whole object to the API which does not exist in the database, this simply rejects it by saying there is nothing to update. I prefer this approach because it forces the API users to use the create operation, covered in section 2, for creating new entities in the database, and to use update for real data updates. We should be attentive to always return meaningful HTTP response codes. In the routes.py file, we define a new route for the /API/candidate/ID, which is handled by the update candidate middleware method and is assigned to the HTTP put verb. The update candidate method receives the ID as parameter. First, we build up a new dictionary from the properties sent in the request body. As you can see, our API at the moment only supports the update of 4 parameters in the candidate entity. Next, we look up the candidate, which has the ID we got in the request URL. If we do not find an entry in the database with that ID, then we return a 204 no content response, saying that the requested resource was not found. Otherwise, we return the updated object. In our data provider service class, the update candidate method first tries to load the candidate with the given ID. If that is found, then it updates the 4 fields and updates the entity in the session. Finally, it commits the changes to the database and reloads the candidate which is returned afterwards. Awesome! We made very good progress. We covered the source code and the theoretical part. Now let's see the API in action. In Postman, I send the put request to the HTTP localhost port 5000/API/candidates, and I specify 5 as the ID of the candidate. In the form data, I specify 4 fields: first name, last name, email, and phone number. These are the fields which I want to update with my API. When I press the send button, I can see that I got a response code of 200. This means that the server successfully processed our request. And in the body of the response I can see the updated candidate details. In this video we have checked what are the characteristics of the update CRUD operation, how this can be implemented in Flask, and we saw how our API in action is using Postman.